Welcome back to the second lecture on demand estimation. So as I told you, we are looking into a concrete application of demand estimation on the basis of a discrete choice model. So we will be looking at a paper that is measuring market power in the ready-to-eat cereal industry, and that is a paper by Nivo that was published in Econometrica in 2001. Before we do that, let me just say one word, maybe that was too quick in the development of what we've said just now. And I'm saying that because we will see this expression of the differences in the logs of the market share, we will see that expression in the application again. But you might ask yourself where this expression comes from, and this relates to the relative odds of probabilities of choice that we saw here when we first looked at this probability of choosing option S, and we were able to express it in this fraction form. So if you have relative odds between the probability of choosing an option L and let's say the outside option K, then you get to this expression of the relative odds. If you take the log of this, then you get to something that looks like that, where you have the difference between logs of Sj and S0. And on the right-hand side, you have, well, the log of the exponential is exactly the argument of the exponential, which is delta j. And then since we say that delta 0 is equal to 0, we normalize the utility of the outside option to 0. Then this contributes a constant where the exponential of 0 is 1, but then if you take the log of that, then that's again 0, so we are left with just the utility of option j, okay, and that is expressed this way. Just a word on where this comes from, as we will see it in our example as well. All right, so we are in the ready-to-eat cereal industry, and basically the one reason why this paper looks at this is the fact that the ready-to-eat cereal industry is a prime example of high concentration. There are only 6 producers that are basically relevant in the US. You have high price-cost margins. There are large advertising to sales ratios. And of course, such margins might suggest that there's collusion, as would the high concentration in this market. One thing to observe is also that there's an aggressive introduction of new products into the market. And so we can get a little bit of a feeling for this market by looking at the main producers and their market shares. So here we have Kellogg's, General Mills, Post, Quaker Oats, Ralston, and Nabisco. And if you look at this first column from 1988, then you can see that these 6 companies, they already make up 95% of the activity, the market share in this market, if you look at the volume sold in this market. All right. Furthermore, you can see that you have a clear market leader with Kellogg's, a clear second with General Mills, and a clear third with Post, and then basically 3 further producers with Quaker Oats, Ralston, and Nabisco. All right. Now, what's the empirical strategy and the data that is used in this study? Interestingly, the supply side of the market will be modeled theoretically. There will be different models of conduct, like, for example, oligopoly with quantity competition, oligopoly with price competition, and so forth. But the interesting feature of this is that there's no data that we have in order to estimate, for example, cost functions or the like. We will have this covered by theories that are modeling conduct. And then for each supply model, and I think that's quite interesting to note because it emphasizes the importance of the demand estimation. For each supply model, the pricing decision depends on demand, right? Which makes sense. And then demand itself is estimated with available data, where the available data is scanner data from the IRI InfoScan database, and that provides you with market shares and prices in each market, where a market would be a particular city in a particular quarter of the year. Furthermore, you have brand characteristics, where I will show you later, one brand might be Kellogg's Cornflakes, right? It's not Kellogg's, but it would be the particular product that is Kellogg's Cornflakes. Then the data includes the advertising, the quarterly advertising nationwide, and it has information on the distribution of demographics in these cities. All right, so if we look at the results, and apologies for the incorrect title here, that should just be the results from the loaded demand regression. Then we see the variables that have been included: price, advertising, the log of median income in the city, the log of median age in that city, and the median household size in that city. And there you can see, we have OLS regressions, the first 3 columns, and then IV regressions. Basically, if we look at the IV regression, they show clearly the negative coefficient of price, indicating that you have downward sloping demand function as you would expect it. As you increase the price, the demand decreases, the market share decreases. Advertising has a positive impact, significantly so. And then just if we stick to this column here as an example, median income increases the consumption, the median age decreases the demand, and the median household size also decreases demand, where, the effect of advertising is quite intuitive, the effect of income, I guess, as well, and then the median age and the household size probably suggest that a lot of the products are predominantly consumed by younger consumers, sometimes maybe kids, and also that maybe smaller household sizes like seniors, they might predominantly not consume so much. Maybe household size might be another way. The presence of kids might be reflected, so that it's rather larger households that have kids, although that would not be in line with the negative coefficient. But yeah, so these are the effects that are estimated, that are mostly intuitive about this demand. And then if you look at the notes here, the dependent variable is the log of S, the market share of product J, minus the log of the market share of the outside option. Right, so this is what we've just derived, and that is what is underlying this estimation here as well. Okay, then let me show you a table of own and cross price elasticities. Here is where this previous title belongs, and I think this gives you an indication of the goods that are represented in this industry. I'm sure many of them Kellogg's Cornflakes being the first one here. And while I think all the products are mentioned in terms of the rows, and not all columns are reported. So you see only a selection of products in these columns, but you can see that clearly the own price elasticity, the element on the diagonal of this matrix, is negative, as you would expect. And then you have estimates for the cross price elasticity, and these estimates are predominantly positive, implying that if the price for, let's say, Cheerios goes up by 1%, then the demand for cornflakes also goes up by 0.127%. Right, so off diagonal we have largely, or as far as I see, exclusively all right, so that would be illustrating nicely that we are able, with this model of demand, we are able to estimate a very large number of elasticities, and that is thanks to us reflecting the utility of these different products on the basis of their characteristics and price and demographics. So this is, I think, showing the power of this approach to microfound the utility of many different products by looking at their characteristics. And so without going in any further detail, the takeaways from this study are quite interesting. And the main takeaway expressed by the author is that prices are consistent with non-collusive pricing behavior, despite the high price cost margins that are observed. Right? So the evaluation of the market power in this study basically suggests that the high price cost margins do not derive from collusion between companies. And even though there are only 6 relevant companies in this market, and it basically comes from the fact that the leading firms in this market are able to maintain a portfolio of differentiated products, and they are able to influence the perceived product quality on the basis of advertising, which maintains this relatively high willingness to pay of consumers that leads to high prices. So here we have this paper that is an example of using demand estimation in order to quantify the market power in an industry. And I mean, this particular paper had some methodological innovations for demand estimation, but it was applied to an example where maybe you go into the analysis with a hypothesis that you would observe market power, but thanks to the rigorous econometric analysis, we actually understand that this is not the case, that there is actually not a high level of market power. I think that's an interesting result of an interesting paper. And that concludes what I wanted to show you on demand estimation. So we can conclude at this point, having seen demand estimation with linear regression, and today having talked about demand estimation on the basis of discrete choice models. All right, I will leave it at that, and hope to see you for the discussion soon. Goodbye.